All right, thanks for stopping by. What I'm going to do today or tonight is to do something I've never done before, and I'm going to go through every single question that's going to be on the test. I'm having a test on Wednesday. Never done this before. This is my 26th year teaching math, and so let's just do it. Let's get started. So here we go. Oops. Let's try that again. Let's try. There we go. All right, so here's number one on the test. Can't believe I'm doing this, but here you go. Now, you can't just write the answers down on the test and memorize it. It'd be hard to memorize 20 questions anyway, or 20 answers anyway, but you're going to have to show me how to get the answers. So I'm going to show you exactly the problems on the test. These aren't like them. They're not similar to them. They are exactly the problems on the test. Oops, already started off wrong. There we go. So this is number one, and you have to factor. So the first 10 are factoring, and you should recognize the first 10 problems because the first 10 problems are exactly what we had on the quiz. I couldn't make this test any easier if I tried. All right, so here we go. So we need to factor this. So this is one of the common factoring problems. So I'm going to factor out a 7. There's a 7 in common with both of those. Factor it out, or you divide it out. So 7x divided by 7 is x. The 7's go, and you're left with an x minus 14 divided by 7 is 2, and that's your answer. Simple as that. Pretty easy to start off with. The next one's just about as easy. This is one of our special kind of factorings, and if you notice it, it's a difference of two squares. You're squaring a number or squaring something to get x squared, and you're squaring something to get 16. So if you remember how to set up a difference of two squares, put your two sets of parentheses, plus and minus, and then what's being squared to give you x squared? Well, x is, so that goes here and here. What's being squared to give you 16? 4 is being squared, so you put it right there and right there, and then that's it. That's all there is to that very basic difference of two squares. All right, number 3 was a little bit tricky. A lot of you got number 3 wrong on the quiz, so let's go through it again. There's a couple ways you could approach this, and I'm just going to do it one particular way. So first thing you do, you always look to see if there's a common factor. Well, there is. There's a 2 here, and there's also a 2 in common with 8, okay, because we can divide out by a 2. So there is a common factor here. So I factor out a 2. That's the first thing I'm going to do. So I get a 1 minus 4x squared. Now, I actually did this differently. I think I went over this when you guys had questions on the quiz. I think I might have gone over this in a different way, but I rethought this, and I think this might be just a little bit easier. Okay, what I did before, I believe, if I remember right, is I made this negative 8x squared plus 2x, then I factor out a negative, and you still get the same answer, but I think this might be a little bit easier. So let's keep going with this. So if you look at this, this is also a difference of two squareds, very similar to this. So you're squaring something to get 1, which is 1. 1 squared is 1. And you're squaring something to get 4x squared, which is a 2x. So I put my two parentheses. And then I always like to do this. Put my signs first. Give me a plus and a minus. And then 1 here, because 1 times 1 is 1. And then the last, all right, the last terms when you multiply have got to be 4x squared, and they're going to be exactly the same. So that's a 2x, and that's a 2x. And that's it. You can't factor any further. You circle that, and that is your answer. Let's keep going. Number 4. All right, this is a trinomial factoring. So it's x squared plus 10x plus 25. Actually, it looks like a regular trinomial factoring. I'm going to move this up just a little bit now. Right there. But it's actually a perfect square. If you look at it, you're squaring something to get x squared, and you're squaring something to get 25. So you're squaring an x here, and you're squaring a 5 to get 25. 5 times x, and you double it, that's 2x. That's the check to see if it's a perfect square. So you could just write it like this. So really, there's really no work involved in this. Just recognize that it's a perfect square, and they're both positive. This will, on a perfect square, this is always going to be positive, so you look to this sign right here, and that's a positive, so you put a plus there. If this was a minus, depending on if the perfect square worked, then you would put a minus here. So anyway, what we do is we just put an x right here. What's being squared to give you 25? 5 is. So you write it just like that. Or if you didn't recognize it was a perfect square, you could have just looked at it as a regular trinomial factoring, and you knew you're going to have an x and an x. Everything's positive, so you put a plus here and a plus here. And then you have to think of two numbers that multiply to be 25, and the same two numbers have to add up to be a 10, right? And that's pretty easy. You only have a couple choices. You got 1 times 25, and you got 5 times 5. So 5 times 5 is going to work because there's no way I can get a 1 and a 25 to add up to a 10. So you put 5 and 5. It's the same exact thing. Okay, I'll put a little or in between there. All right, so you've got this or this. It's the same exact thing. I would accept either one. This is the easiest way, I think, to do, is to just recognize that it's a perfect square. All right, let's do another one. Number 5. All right, this is just a regular trinomial factoring. This is not a perfect square. It's not one of our special kind of factorings. Plus 21. Okay, so you take a look at it. First thing we're going to do is recognize that it's a trinomial factoring, so we put some parentheses there. What I like to do is think about what my signs are going to be first before I do anything else. Oh, I could put an x here because you know x times x is x squared. But look at the sign right here. This number, the last two numbers, okay, this one right here and this one here have to multiply to be positive 21, and they have to add up to be a negative 10. So think of your signs. They both can't be positive because there's no way I can get two positive numbers to add up to be a negative. Okay, but I can get two negatives to add up to be a negative, and those two negatives multiply to be positive. So I know they're both going to be negative. I think that's important to do. All right, and then now you got to think of your numbers. Again, you don't have any choices with this. This is not one of those ones that's really difficult and you got all kinds of choices. You basically only have two choices. You have 1 times 21 and you have 3 times 7, or 7 times 3. It's the same thing. There's no way I can get a 21 and a 1 to add up to be a negative 10, but I can get a 7 and 3. So if I put a 7 and a 3 here, negative 7 times negative 3 is positive 21, and when I add them up, negative 7 plus negative 3 is negative 10. That works. That is factored. All right. I'm going to keep going. Tell you what, let's change colors. I'm tired of just this black and white. Let's go to this nice blue. I'm not shining this on the screen in the classroom, so it should be a little easier to see. All right. Number 6 on the test. It's 3x squared. This time you have a number in front of that x squared. But we can get rid of that pretty easy if you take a look at the rest of this. All right. So if you take a look at this, the first thing you do when you factor problems is see if it has any common factors. Well, you have a 3, a 12, and a 36. You should recognize that right away, that there's a 3 that divides into each of these 3 terms. So I'm going to factor it out. Or I'm going to divide everything by a 3 is what I'm doing. When I say factor it out, it means I'm dividing it by a 3. So if I take this and divide it by a 3, the 3's cancel, and I'm just left with an x squared. Put a minus. If I take this and divide by 3, 12 divided by, if I could talk, 12 divided by 3 is 4x. Put a minus. 36 divided by 3 is 12. Now, we turned it into a regular trinomial factoring. Don't forget about that 3, though. Keep that 3 right there. It's still being multiplied by everything. So I put my parentheses here. Now, I'm going to put an x and an x because I know x times x is x squared. Now look at my signs. Remember the last terms right here, the last two have to multiply to be a negative. So when I multiply two numbers and I get a negative answer, one has to be positive and one has to be negative. All right, I could have put the plus over here or the minus over here. But now we have to think of some things. Now we have a couple choices. We have actually 3 choices, kind of. What multiplies to be 12 and adds up to be a negative 4? If you want to write it down, you can write it down. So just think. Now, I'm not going to put the signs in here. We'll talk about the signs in a second. But what times what is 12? Well, 1 times 12 is 12. 2 times 6 is 12. And 3 times 4 is 12. Of course, you can go the opposite direction. Now, remember, one's got to be plus, one's got to be minus. So is there any way that I can add these up with one being plus and one being minus to give you a negative 4? Can I get 1 and 12, either a negative 1 plus 12 or a 1 plus negative 12? Is there any way I can get a negative 4 out of that? There's not. Let's jump down to this one, 3 and 4. Is there any way, if this is negative 3 or if this is negative 4, could I add them up and get a negative 4? No, obviously I can't. So what about here? Yeah, that's the one. 2 and 6. Now, which one has to be negative? Well, if I add up the two numbers and I get a negative answer, the largest number has to be the negative. So the 6, sorry, it's a weird looking negative sign. Let's try that again. Just put a little minus right there. So 2 times negative 6 is negative 12, and 2 plus negative 6 is negative 4. So the 2 has to go with the positive. It does matter where the 2 goes. You can't put the 2 right here. The 2 has to be positive, and the 6 has to be negative, and that's your answer right there. So we circle it, and we are finished. That's number 6. Let's try a different color. All right, let's go to number 7. It's more factoring. 1 through 10 are all factoring. Now, 11 through 20, there's going to be factoring, I believe, in every single one of those problems. So if you don't know factoring on this test, you better learn it pretty quick before we take the test on Wednesday. So, but we've been going over it a long time here. All right, here's a factoring right here. What I'm going to do on this problem is let's take a look at it. First of all, are there any common factors here? I got a 4 and a 12, so you're like, oh yeah, 4 goes into that, but 4 doesn't divide into 9, so we can't do that. Well, 3 goes into 12 and 9, but 3 doesn't go into 4, so I can't factor out a common factor. So what I'm going to have to do is just think about this a little bit more. But if you look very carefully, this is one of our special factorings, 4x squared. Am I squaring something to get 4x squared? Sure I am. I'm squaring a 2x. Am I squaring something to get a 9? Yeah, I'm squaring a 3. So this right here is a perfect square. All right, so actually, I'm sorry. You can't just stop right there. There's one more thing you got to check. All right, what are you squaring to get 4x squared? You're squaring a 2x. Okay, what are you squaring to get a 9? You're squaring a 3. How do we check to see if this is a perfect square? We multiply the two numbers that are being squared, which is 2x times 3, which is 6x, and then you have to, remember, double it. And what is that? That's 12x. Is that middle term right there 12x? Yes, it is. So if you check those three things, can you square something to get this? Yes. Can you square something to get this? Yes. Take those two numbers, multiply them together, double it. If that's true, if this works, if this is a 12x and this is a 12x, then it's a perfect square. So if you can recognize that, all you got to do is put a little squared here. Everything's positive, but you always look at this sign right here. That sign is going to go right here. And what's being squared to give you 4x squared? 2x. What's being squared to give you 9? 3. That's all you got to do. It's that easy. All right. I'm almost waiting to take questions, but you're not with me live anyway, so I can't take any questions. So you just have to rewind it and go back and watch. All right, here we go. We went over this before we took the quiz. We might have done it even the day we took the quiz, because I took a couple minutes before we took the quiz and asked for questions, and I think this was one of them. We did it right on the board before we took the quiz. And then, like the day after or whatever it was, I think we went over it. So let's do it one more time. So this will be the second time that you see this. Actually, the third time. This is right from the homework. I think we went over it on the homework is what I was thinking. Then we did it on the quiz. We reviewed it, went over on the quiz, and now we're going to do it again. So we need to factor this. This is, again, 1 through 10 is all factoring. So first of all, is there anything in common with both of these terms right here? Well, there's an x to the 5th in both of them. So I factor out an x to the 5th. I'm not going to sit and explain why there's an x to the 5th in both of them. We've done that before. I'm just showing you how to do the problems. So if you factor out an x to the 5th, I've said this many, many, many times. When I say factor it out, it means to divide it out. So x to the 7th divided by x to the 5th is x squared. If you don't know how we got that, you're going to have to go back and look to see the rules for dividing with exponents. All right, just don't have time to go through every single rule here. X to the 5th divided by x to the 5th is 1. Anything divided by itself is 1. Now, don't circle this. Okay, we've got to factor it completely, and that's what the instructions say. They don't just say factor like I wrote on the screen up here. It says factor completely. This is not factored completely. This, you can still factor x squared minus 1. So I'm going to put the x to the 5th right here. This is a difference of two squares. We've already done a couple difference of two squares, and then we put an x here, a plus, and a minus, and then what's being squared to give you 1? 1 is 1 times 1. Now it's completely factored And that's your answer right there. All right, it looks a little confusing at first. Like, what in the world are we supposed to do with that? But I hope that made sense. All right, we're almost done the first half. Couple more. Well, I tell you what, I'm going to scooch this down. This one's a little, oops, not across. Come on, there we go. Scooch it down, and let's do number 9 right here. I just need a little bit more room. So this is kind of long to write, or the problem to write out is kind of long. Doing the problem, it's not so bad, but it looks crazy. It's 4, but it's kind of the same stuff that we just finished doing. It just looks a little bit more, I don't know, weird. So first thing I'm going to do, what am I going to do? A lot of people would look at this and say, oh, distribute the 3. But remember what the instructions are. The instructions are to factor this. So we need to take this whole thing right here and factor it. What times what is this stuff right here? So let's do that. If you look at it, it's a perfect square. X squared plus, you're squaring something to get x squared. You're squaring something to get 25. In fact, I think we did this exact one, didn't we? Yeah, that was number 4. We did this exact problem as number 4, so you should know how to factor that. I'm just going to do it for you. I'm not going to write it, though, as a parentheses and squared. I'll show you why in a second. I mean, you could, but I like to do it like this. So it's going to be x plus 5 and x plus 5. We already did this in number 4. And then let's rewrite this. Again, don't distribute that 4. We're defeating the purpose. The whole purpose is to factor it. Find out what times what is equal to all this stuff. That's what factoring is. Now you take a look at this. Look, you got this big thing right there, and you got this thing right there. Those are our 2 terms. And we have to figure out, is there anything in common with both of those terms? Well, sure there is. There's an x plus 5 in here, and in fact, there's 2 of them. But there is an x plus 5 here, and there's an x plus 5 right here. So it's in common with both of these terms. So what do we do with a common factor? We factor it out. So I'm going to pull an x plus 5 out. I'm going to divide it out of each of these terms. So what's left over? I'm going to put a big parentheses here because I'm going to put a lot of stuff in here. And I'll put some other parentheses in here as well. You could put a bracket here if you wanted to. I'm just going to put an extra big parentheses. So if I pull out an x plus 5 from this, what am I left with? Well, I'm left with a 3 times x plus 5. Minus, if I pull out an x plus 5 from this, right, divide this thing by x plus 5, the x plus 5's cancel. What am I left with? Just a 4. Okay? Now, this is not in simplest form. We got to put this in simplest form. So I'm going to keep this x plus 5 right here. See that big old parentheses right there? I want to simplify this a little bit. So now, in this situation, there's nothing else we can do inside here to factor this. So we're done factoring inside of there. There's nothing in common with this and this, so you can't factor it anymore. So we're just going to make it look a little bit nicer. So what I'm going to do is take that 3 and distribute it through that first parentheses. So I have a 3x plus 15 minus 4. Okay, so I already took care of that parentheses because I multiplied that through. I got a minus 4 right there, and I'm good to go. I'm not going to leave it like that. I am just going to add my like terms. I got a positive 15 and a minus 4, so 15 minus 4 is 11, so it's 3x. It's positive, so it's plus 11, and then that is in factored form. Remember what we're trying to do? We're trying to factor. We're trying to find what times what is equal to that initial problem that we had up there. Okay, that's what we're trying to do. And so x plus 5 times 3x plus 11, those 2 things multiplied together will equal all this stuff up here. That's what we're trying to do. All right, let's do another one. Do number 10. Let's go green on this one. Let's scoot this up. All right, so we're about halfway through. It's not so bad, is it? I don't know. I say that all the time, but maybe it is so bad. If it is, then go back and look at some of the old lessons. Go through these problems again. Minus 2. All right. So what we need to do on this is one of those factoring by groupings. And this is just a little bit more complicated because you got this minus sign right here. But I'll show you what we're going to do. Let's just change colors real quick here. So what I'm going to do is factor by grouping. So what I want to do is put a parentheses around this and this, because I see a common factor with these two right here. I see an x squared in both of these. All right, so I'm going to factor out an x squared from this. Now, there is nothing in common with this x and this minus 2, but I'm just going to put that in parentheses. But watch very carefully. Watch what I'm going to do. I am not going to just put a parentheses around this. If I do that, remember what this was. This was negative x minus 2. Okay, negative x and then minus 2. By putting parentheses around this, I technically change it to negative x plus 2, because minus a negative would be a plus. In order to keep it what it was originally, I'm going to put that as a plus. Okay? So now, is this what it originally was? Sure, it's x cubed plus 2x squared. That didn't change by that parentheses, but look at this. Now it is minus x, what? Minus 2. That's what it was originally. So if you put parentheses around here and you got a negative outside, you got to change that negative to a positive, because when I distribute the negative, it's negative x minus 2. I hope that made sense. If not, go back to the lesson again where I first taught this, and I think I talked about that a little bit better. So now let's figure out what we have here. Let's factor out what we can factor. So we said there's an x squared in common in both of these. That's kind of like that x to the 7th minus x to the 5th problem that we did earlier. That was number 8. All right, so what's in common with both of these? An x squared is. So let's figure out what's left over when I take out an x squared. So x cubed divided by x squared is just x, plus 2x squared divided by x squared. The x squareds cancel out, and I just have a 2. Now look at this. Now I have a minus. I'll just keep that in parentheses. It's important because you're distributing the negative through here. Now take a look at this next step. This next step, I have an x plus 2 in common. Remember, we're looking at this term, right? The terms are separated by pluses and minuses. So I'm looking at that term and I'm looking at that term. There is something in common with both of these. They both have an x plus 2. So what am I going to do with that? I'm going to factor out the common factor. So I'm going to factor out an x plus 2. I'm going to divide out by an x plus 2. So if I take this and divide by an x plus 2, I'm left, let's put parentheses there, I'm left with an x squared. Put a minus. What if I factor out an x plus 2 from this? If I pull it out, it looks like there's nothing left. But remember what I'm doing. I'm dividing. So what's x plus 2 divided by x plus 2? Well, anything divided by itself is 1, so x plus 2 divided by x plus 2 is 1. We encountered this earlier, the x squared minus 1. Remember, this is not factored completely yet. Don't circle this and leave that as your answer, because it's not correct, because it says factor completely. So I can't factor the x plus 2. I'm going to keep it the way it is. And this is a perfect square. I'm sorry, it's a difference of 2 squares. And so it's going to be x plus 1, x minus 1. We've already done that. I don't need to explain it. That right there is your answer for number 10. All right. Enough of that. That's all old stuff. You've seen those problems before. You've seen them on homeworks. You've seen them on a quiz. So that's at least the 3rd time that you've seen those problems. All right. So let's do 11. This one says, it says reduce each rational expression to lowest terms. Reduce. A rational expression. This whole chapter, or section, I should say, of R7 is rational expressions. And we're reducing it to lowest terms. All right, so number 11, let's write it out. These kind of look ugly because they're fractions, and I know nobody likes fractions. But once you learn the rules for them, they're really not so bad. Said it again, didn't I? Sorry about that. All right, let's reduce this. So can I just cancel stuff out? Can I cancel out this x with this x, and 2 divides into 6? No, it doesn't, because this and this are being subtracted. Same thing with these right here. You cannot cancel stuff out, top and bottom, if they're being added or subtracted to something. They have to be multiplied by something else. And you're like, Mr. Hamrick, the 2 and the x are being multiplied times each other. But this term, this whole term right here, is not being multiplied by something else. It's being subtracted from the x squared. Same thing with these 2 things down here. So let me just go through how to do it. First thing we're going to do is we're going to factor, just like we did this whole, like I said, every single one of these problems, 1 through 20, you have to factor. So I hope you're good at this. So, because we're doing a lot of it. So what's in common with these two right here? Well, an x is. So an x is in common, so what am I left with? X minus 2. What's common down here? A 3 is in common down here. So I've got an x minus 2. Now take a look at it. Now we got an x minus 2 on the top and x minus 2 on the bottom. Can they cancel now? Yeah, they can, because this whole x minus 2 now is being multiplied by something else, right? Just like I said earlier. This x minus 2 right here is also being multiplied by something else. Now you can cancel them out. They divide each other out because multiplication and division are inverse operations of each other and they undo each other. So the x minus 2 cancels with this x minus 2. What are you left with? You're left with an x on the top, a 3 on the bottom, and that's your answer right there. That's all there is to it. All right? Let's do another. Number 12. It's kind of the same thing. Just the factoring is just a little bit different. And I got x squared minus 2x plus 1. All right. So again, we got to reduce it to lowest terms, which means we want to cancel stuff out. You can't cancel this. You cannot cancel the x squared and the x squared because this x squared is being added to something else. So you cannot cancel it out. You can't stress that enough. Students try to do that all the time. All right, let's go through. We're going to factor this thing right here. And this is a fairly easy factoring. It's a trinomial factoring. Both of them are. Actually, this is a perfect square, but you can look at it as a trinomial factoring. So I'm going to put my 2 sets of parentheses. I'm going to do it top and bottom. All right, let's see what we get in here. So what's my numbers? I got 1 times 5. It's the only thing that equals 5. So how in the world am I going to get that to add up to 4? Well, if the 5 is positive and the 1 is negative, then that'll work. So I'm going to put an x here and x here. You're going to have 1 positive, 1 negative. And again, the bigger number has to be positive because it has to add up to a positive 4. So I'm going to have 5 and a 1. Do they multiply to be negative 5? Yes. Do they add up to be a positive 4? Yes, it's factored. Right here, you put an x here and an x here. They have to multiply to be negative 1 and add up to be negative 2. So they're both going to be negative, and you're going to put a 1 here and a 1 here. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So it works. Now, take a look. This and this are being multiplied. This down here and this down here are being multiplied. So if there's something that's the same on the top and the bottom, now they can cancel out. So the x minus 1 cancels with the x minus 1, and look what I'm left with. I'm left with an x plus 5 over x minus 1, and that is your answer. It's reduced to lowest terms. Can you cancel out the x's? No. Okay, for the 4th or 5th time, you cannot cancel out this because it's being added to the 5. This is being, or the 1's being subtracted from the x. You cannot cancel these, only if it's being multiplied. This and this were being multiplied, so were these, so now you can cancel them out. Same deal with that right there. All right, we're getting there. Number 13. It's taken me a lot longer to do this because I'm explaining everything, but to actually just do the problems, it shouldn't take you quite as long as it's taken me. All right, let's do number 13, lucky 13. All right, we got a 3x plus 6 over 5x squared. You got a little dot in the middle, means you're going to multiply, and it's x over x squared minus 4. Now, the instructions. The instructions say, perform the indicated operation. So what's the operation? It's multiplication right there. So perform the operation, and it says leave your answer in factored form. We'll talk about that when we get to the end. Okay, leave your answer in factored form. That's exactly what they say on the problems in the book, or in the book. All right, so I did it the same exact thing. So let's do it this way. So first of all, before we start canceling stuff out, we could actually cancel something out right now, like this x, because this x is being multiplied by that whole thing right there. This 5x squared is being multiplied by this whole thing right there. So technically, this x and this x could cancel each other out. I'm going to wait and do it in the next step. We got a couple things we can do here. What can we do with this 3x plus 6? we can factor it out. So it's 3 times x plus 2. And then if I'm going to multiply, I'm just multiplying it straight across. I could just put an x right there if I wanted. Let's do that. You don't even need the dot, do you? If it's just next to it, it means it's multiplied. Then I got a 5x squared right here times, look at this. This is a difference of 2 squares. So I can put this and this, x, and then I'm going to get a plus 2 and a minus 2. Again, I'm not going over how to factor these because we've already talked about that. Now what we can do is start canceling stuff out. Let's do that x. I said we wanted to cancel out anyway, so let's do that. So this x cancels out. Look, I got an x squared right here. It only cancels out with one of those x's. I still have an x left over. So one of these cancels with one of these. I still got one left over because I had x squared, x times x. So that canceled. Is there anything else that cancels? Yeah, look, the x plus 2, and I got an x plus 2 right here. Why do they cancel now? They cancel now because the x plus 2 was being multiplied by everything else. This x plus 2 was being multiplied by everything else. That way, I can get rid of them. Bam, right there. And let's just write our answer. What's left on top? Just a 3. And what's left on bottom? It's 5x, and it's an x minus 2. Remember what the problem said. I said I'd get to it at the end. It says leave the answer in factored form. You do not have to distribute this through. All right, leave it in factored form. It's in factored form right here. Just leave it like that. Nothing else cancels. If nothing else cancels, you just leave it like that, and you should be good to go. All right. That's 13. Oh, 14. Wow. I wish I had a way, when I record these lessons, let's go white. I can't pause it. For this program that I use, there's no pause button. I wish they would put a pause button on here, and then I could just write it out and bam, you could see it. So I'm just going to have to write it out for you, sorry. Or I could have done some more preparation and had it already written out. But take what you can get. X squared plus x minus 6. All right, now watch this crazy thing. That's a fraction, but it's actually being divided by something else. It's x squared plus 5x minus 6 over x squared. It looks like the same thing, but it's not quite. 5x plus 6. You're like, what in the world's going on here? Well, this is a big old division problem. Remember what division is. What is it? We keep, we flip, no, we change, and we flip. Almost did KFC. It's KCF. Keep, and we change the sign, and we flip it. Or the way I used to say it was we just multiplied by the reciprocal. So we take the top, we keep it exactly the same, and then we multiply by the reciprocal. So I'm going to put an equals sign right here. And since I can do this on my little computer program here, I'm just going to keep that the same. All right, and let's get the pen there. Oops, I'm sorry, what am I doing? Tell you what, I don't even need it up that high. Let's put it about right there. Yeah, that's better. I'm going to keep, right? So that stayed the same. I'm going to change from division to what? Multiplication. And I'm going to take this and I'm going to flip it. All right, let's see if I can do that. Copy, paste. See what it was on the bottom, right? So this was on the bottom and now it's on the top. Let's see if I can grab this. With all that junk in there. There we go. Copy, paste. I think I missed a little bit of that 5. Just put that in there, and then we just put division right there. So what did I do? I kept the top the same, changed it from division to multiplication, and I flipped the bottom. X squared plus 5x plus 6 goes on top, and then the x squared plus 5x minus 6, which was on top, now goes on the bottom. That's the first thing I would do. That's the division. That took care of that division. Now, it's just 4 factoring problems, and then you cancel stuff out. So let's do it kind of quick here. So I'm going to do this top one right here, x squared plus 7x plus 6. I'm going to factor it and put it here. And then the bottom one, the x squared plus 6 minus 6, is going to go right here. And then I'm going to do the same thing here. Put parentheses. Okay, I'm just getting ready to stick numbers in here. There we go. So that's what I'm going to do. I'm going to take this, factor it, put it here, put it here, put this here, put this here. All right, let's do it. This is all plus, so it's pretty easy. What, 6 and 1, right? So x and x, they're both, everything's positive, so plus, plus, 6 and 1. They multiply to be 6, they add up to be 1. Let's do the bottom. So put an x and an x. They multiply to be a negative, so one's plus and one's minus. So I'm going to use 3 and 2. It's going to be a positive 3 and a negative 2. Multiplies to be negative 6, adds up to be positive, what? 1, because there's a 1 right there. Let's do this. 3 and 2, right? Yeah, I only have two choices, 6 and 1 and 3 and 2. So 3 and 2 add up to 5, and they multiply to be 6. That works for me. And then let's take a look at this one. Let's see, I'm just looking at my notes here. Just want to make sure I'm doing the right thing. All right, so I've got x and x right here. Again, it multiplies to be a negative, so one's going to be positive, one's going to be negative. So what are we going to use? Are we going to use 3 and 2 here? No, because if I subtract, there's no way I can take 3 and 2 and subtract them and get a 5. So I'm going to use 6 and 1, and my answer is positive, so the bigger number, the 6, is going to be positive. So 6 and 1. All right, multiplies to be negative 6 and adds up to be positive 5. So I factored those. You should be really quick at doing those regular trinomial factorings, especially when the numbers are that easy. All right, let's see what we got. Let's start knocking things off. An x plus 6. Do I have an x plus 6 on the bottom? Sure enough, I got it right there. So bang, bang. I got rid of the x plus 6s. Anything else? X plus 1. Now, I got x minus 1, so I can't cancel those out. What else do I got? An x plus 3. Well, I got an x plus 3 down here, so they cancel. An x plus 2. Nope, no x plus 2s down here. Nothing else will cancel, so we write our answer as x plus 1 and times x plus 2 over, what's on the bottom? X minus 2. And what else is there? X minus 1. Remember, these are not the same exact things, so you can't cancel those out. The only thing you can do is leave it like that. Don't multiply them through. Don't use the FOIL method and get another answer. Technically, it would be right, but the problem says leave your answer in factored form, so really it wouldn't be right because the instructions say leave it like this. All right? So that was number 14. I didn't write the number 14 next to it, but it was number 14. Can you read the red? Let me see. Yeah, I can see that pretty well. Hopefully you can see it on your computer or tablet or phone or whatever you're watching this on. All right, so we're doing number 15. So it's 2x minus 5 over 3x plus 2. And now you're adding. So we did multiplication and division. Now we're going to do addition, which throws a monkey wrench into the situation. But this one's actually pretty easy. The next one is too. Okay, after that, it's a little bit tougher, but these are pretty easy because what do you do when you add fractions? What's the thing that you have to find? You have to find a common denominator. Well, check it out. I was nice enough, or the book was, to give you common denominators already. So that makes it super easy. So I can put everything over the common denominator. Do not try to add the denominators together. Do not put 6x plus 4. It's not how you add fractions. If you have the same denominator, you keep the denominator the same, and then you just add the top. So what do we have? I'm just going to write it out so I don't confuse you. 2x minus 5 plus x plus 4. I'm going to just jot it down here. So the denominator stays the same. I didn't do anything with that. Let's add the like terms. 2x plus x is 3x. Negative 5 plus 4 is negative 1. That's your answer right there. You cannot cancel out the 3's or the x's because it's being added or subtracted to other stuff. So that's how you do number 15. Let's do another one. Have we done this purple yet? I don't know. So now we're doing number 16. This is subtraction. But the nice thing is on this problem is you have common denominators again. And that denominator is 3x plus 4. But now you have a minus sign, which adds a little bit of extra thinking to this. Here's what you have to understand. When you're subtracting the whole entire denominator. I think it's really important to parentheses around this. It's not just negative x plus 1. It's actually, if you put parentheses around this, it's negative x minus 1. All right, that's super important right there. Okay, put a little arrow there. That parentheses is really, really important. So it's got a common denominator already, so that's nice. So I just keep it the same. And now I just add up the top. So 5x minus 4. Now look what we have. We have minus x minus 1. That's super important. I think if anybody messes this up, that's probably where you'd mess it up. You'd probably put a 1 there, plus 1, I'm sorry. But it's a minus 1 because you're subtracting the entire numerator. So you got to put parentheses around the whole numerator. That negative is being distributed through that numerator. That's really important. That's the hardest part of doing that problem right there. The denominator definitely is the easy part of doing that. Let's see what we get. Let's add up some like terms. 5x minus x, which is 4x. And then negative 4 minus 1 is negative 5. And then that's it. Don't try to cancel anything. That 4 doesn't cancel. The x doesn't cancel. You leave it like that, and you're good to go. Brown. I've never used brown. That looks all right, I guess. 17, or tan. All right, let's write this down. So 3x over x minus... Now, don't expect me to do this on other tests. This is probably the only time all year I'm going to do this. And basically, I'm just doing this because it's at the end of the marking period. There's a few of you that really, really need a good grade on this. And I'm trying to do everything I possibly can to help you out. All right. So if you take a look at the denominators, they are different this time. You got an x minus 4 and an x plus 3. Well, how do you find a common denominator? One way is just multiply the denominators, and that's what we're going to do right here. We're just going to multiply the two denominators together. So it's x minus 4, x plus 3. You don't have to distribute. Don't do FOIL method and get some, trinomial down here. Keep it in factored form. Then over here, I'm going to keep it the same, x minus 4, x plus 3. All right. So here's the question that I always ask. What did you do to that denominator in order to get this new denominator? You multiplied this by something. By what? By x plus 3. So you go back, and if you multiply this by x plus 3, you got to multiply this by x plus 3. All right, that's really important. All right, let's change back colors. Now let's go ahead and do our distribute. You could have written it up here and then just done a whole bunch of steps, but I already stuck it here. Let's figure out what this is. You have to multiply this by x plus 3 because you did that to the bottom. Because x plus 3 over x plus 3 is 1, you're allowed to do that. I explained that in the lesson. Let's just do the problem. So it's 3x times x, which is 3x squared, plus 3x times 3, which is 9x. All right. So this right here is the exact same thing as what we started with. Let's do the same thing over here. What did we multiply this by in order to get this denominator right here? Well, let me change colors. We multiplied it by an x minus 4, right? Because you got an x minus 4, x plus 3. What do we do to this? We multiply it by an x minus 4. So what do we do up here? We multiply that by an x minus 4 as well. Let's multiply this out and see what we get. We get 2x times x, which is 2x squared, and then minus 2x times 4, which is an 8x. All right, we'll get rid of these arrows. Get that out of the way. All right. So now what we can do, now we have a common denominator. By multiplying those two together, we have a common denominator. So I'm just going to write my denominator as x minus 4 and keep it in factored form. Don't multiply it out. And then let's add up our like terms up here. Okay, we can do that. We've got all like terms. It's a plus, which makes it easy. I don't have to worry about putting parentheses around stuff. So I got a 3x squared plus 2x squared, which is a 5x squared. And then I got a 9x plus a negative or minus 9x minus 8x, which is just a 1x, or just plus. It's a positive, right? Because positive 9 minus 8 is positive x. So it's a positive x right there. That's how I would like you to leave the answer. Okay? you don't have to factor out a common x. I know it says leave it in factored form, but once you've multiplied, or once you've added up your like terms, you can just keep it like that. It's perfectly fine to keep it like that. All right. Getting there, getting there. What do we got? 3 more? All right. Let's try this green. All right. 18. I got an x over x squared plus 3x plus 2. Plus, oh, another addition of fractions. 2x minus 3 is on top, and x squared minus 1 is on the bottom. Now, this one's a little more complicated, but the first thing we're going to do is this. You recognize this stuff. We've been doing this the whole entire test, or yeah, the whole entire test. Well, I don't know. With the addition of subtraction, I don't think we did any factoring with that, did we? I said we did it on all 20 of them, but yeah, we really didn't. But this one you will have to factor. So let's factor out this and see what we get. All right, put an x on the top. Let's factor out this because it's going to help us find a common denominator. Man, if you just try to find a common denominator using this and this, oh my word, that'd be hard. So what I'm going to do is factor it. All right, so let's do that. This is an easy one. So it's plus 2 plus 1. Why is it easy? Because 2 times 1 is 2. 2 plus 1 is 3. That's how you factor that one. This is just about as easy, maybe even easier. We've done this a couple times, I think, already on this test. X squared minus 1. It's a difference of 2 squares, so it's an x plus 1 and it's x minus 1. All right, so what we're going to do, let me move this up just a tad. What we're going to do is find a common denominator. You could just multiply them together, but remember the little trick that I showed you to find a common denominator, or at least common multiple? Find out which ones show up, right? So I've got this group right here, and I got this group right here. So find out which ones show up in each group, all right? And then we're going to pull them out. Let's talk about it. So I got an x plus 2 right here. Do I have an x plus 2 over here? No. So how many times does it show up? Just that once. So I'm going to pull out an x plus 2. Remember, this is going to be our denominator. All right. What else shows up? An x plus 1. Well, I got an x plus 1 here and an x plus 1 here. This is where it gets a little bit tricky. I got 1 here and I got 1 here. Now, you're not going to pull out both of them. You're just going to use one of them. It only shows up once here, and it only shows up once here. So since it only shows up once in either one of those places, I'm just going to pull it out once, not twice. There's a reasoning behind that. I'm not going to worry about that right now. I just want to show you how to do this problem. What else shows up? I already pulled out an x plus 2. I already pulled out an x plus 1. What else is here? An x minus 1. Even though it's not over here, it's fine. It does show up, though. So it shows up, and I include it. That's my least common multiple. That's my common denominator. So what I need to do now is figure out what I am going to get for my numerators. So what did you do to this to get that big old denominator right there? Well, you multiplied. I already got an x plus 2. I already got an x plus 1, so I didn't really do anything to those. What's the only thing that's missing? An x minus 1. So I have to multiply the bottom by an x minus 1 to get to this, so I also have to multiply the top by an x minus 1. All right? Let's do the same thing over here, and then we'll do all the multiplication and addition together. So what did I have to do to this in order to get to this big old denominator? Well, it already has an x plus 1. It already has an x minus 1. What doesn't it have? It doesn't have an x plus 2. So I had to multiply the bottom by an x plus 2. So that means I multiply the top by an x plus 2. Now you got to be careful here. See that 2x minus 1? I got to put that in parentheses because I'm going to have to distribute this. So this is a little bit more complicated, but it's, you know, steps that you already know how to do. Let's get rid of that big old arrow and let's get rid of this ugly circle. Okay, and let's go back to green. All right, so now what I'm going to have to do is multiply and stick it down here. So let's multiply these together and put it in the numerator. So it's just little distributive property, so it's x squared minus x. Put a plus here because of this plus. Let's do this. This is just FOIL method. So it's 2x times x, which is 2x squared. Can we do the outside and inside together? Yeah, let's try that. So the outside is 2x times 2, which is 4x. The inside is minus 1x. So 4x minus 1x is positive 3x. All right, if you need to do that in an extra step or off to the side, feel free to do that. But I think at this point we should be able to do that in our head. And what's the last? So we did first, outside, inside. Now we're doing the last. -1 times 2 is -2. We're not finished. We have to add up all our like terms. Tell you what, just for the sake of time, I'm going to copy and paste. Hopefully I can grab it. There we go. So I don't have to rewrite it all again. All right, now let's add some like terms. So I got an x squared and an x squared. 1x squared plus 2x squared is 3x squared. So I've taken care of that one. I've taken care of that one. Now I got a -1x, right? If there's no number, it's always a 1. So -1x plus 3x. So -1 plus 3 is +2x. So I'm done with that one. What's left over? Just a -2 or -2. And then that is your answer. That's how you leave it. I wrote something a little different. Why did I do that? Give me a second. Let me take a look at this. X plus 1, 2x plus 3. This is where it'd be nice to have a pause button. X squared minus x, yeah, plus 2x plus... Oh, what did I do? I made a mistake somewhere. Or maybe I made a mistake when I did my answer key. I think it was in here. It's 2x squared, okay, plus 4x. Why did I put a 3 there? Oh, I think I know why. Because I think I wrote the problem down. No? Did I write the problem right here? Yeah. 2x. Oh, that's what I did. Oh, my word. Are you going crazy? Am I going crazy? See that 3 right there? And stupid me. Why did I put a 1 there? Probably I saw that 1 and put it there. I'll tell you what. I'm not going to go through that whole entire thing again. That was my fault. And it wasn't even a math problem or a mistake. It was just not writing that down correctly. That was a 3. So really what I did with that 1 being right here, I did from here on, I think I did it right. I just didn't put the 3 where it's supposed to be right here. So I will tell you what the answer is to this problem right there. So it actually comes out to this, 3x squared minus 6 over, and then that denominator is exactly the same. So I can just take that whole thing right there, copy and paste it, and then put it right there. So I'm sorry about that. I make mistakes too. Yeah, that's what I did. So if you want to try it, right, stick the 3 here, distribute it. It's just going to change a couple things. It shouldn't be that hard to figure out. But this is what the answer should be if this was a 3, like it was supposed to be. All right, but I stuck a 1 there. That was dumb. But that was a mistake I made, and that's why you double check, okay? You go through when you're taking the test, especially if you have some extra time. Don't turn it in early. Check to see if you make mistakes like that. And I would have, unless I would have gone back and checked it. Well, sorry about that, but there you go. That's what happens when you do this live. Well, it's live for me anyway, even though you're watching it at a different time. Let's do 19 now. So I could have paused it and gone back, or I could edit it, but I'm not going to. I'm going to leave it in there. I'll show all my mistakes. All right, this is number 19. This is a minus, and just a 2 on the top, and x squared plus x minus 6. All right, let's see what we got to do here. Well, again, it's a subtraction of fractions. I don't have common denominators, so what do you think I'm going to do? I am going to find a common denominator. Before I do that, though, I'm going to factor these denominators because I can. All right, it's a difference of 2 squares. I think we've already done that exact one before, so it's an x plus 2 and it's an x minus 2. Extend that a little bit, put a minus, and let's factor this right here. So it's a trinomial factoring. Put an x and an x. So what multiplies to be -6 and adds up to be +1? Well, that would be a +3 and a -2. Multiplies to be -6, adds up to be a +1. And there we go. Put a 2 on the top. So now we have to find a common denominator. Let me scooch this up a little bit. Find a common denominator just like we did before. The only thing different on this one is you got that minus sign right there. Okay, so let's do this. Let's put a minus in the 2 bars. So what do we do to find our common denominator? Well, in fact, let's do this. Let's just make one big old denominator, I think. Yeah, let's do that. So what do? We find out what shows up. Well, we got an x plus 2, and I don't have any x plus 2's anywhere else. I'm just going to put an x plus 2 here. I got an x minus 2 here and here. Remember, I only pull out one of them. I already talked about that in the last problem. And then what else do we have? An x plus 3. That's my common denominator. Now, what did we do to this to get to this? Well, we multiplied by an x plus 3. I'm not going to do the circles and arrows and all that. Multiply this by an x plus 3, and I'm even going to keep this the same color. And now we just multiply that out. What did you do to this denominator to get to this? Well, I already got an x plus 3, got an x minus 2. What don't I have? An x plus 2. So I multiply this by an x plus 2. Hopefully I wrote the problems down right. What do we get? We got 4x squared plus 12x minus, now you got to be careful here. Okay, this is a negative 2, if you want to think of it. Watch. I'll put it a little closer so it looks like this. This is where it gets a little scary in here, okay, with this negative stuff. So basically, it's just negative 2 times x plus 2. So what are you going to get if you had that? That's a negative 2x minus 4. That's where a lot of you might go wrong if you didn't watch this video and I told you, okay, to look out for it. So there you go. You got that. Let's see, did I still have that? Nope, that's the wrong. I thought I had copied this. So let's just do this. Let's copy and paste that. Oops. Oh my goodness. Let's try this again. So copy, paste. If I can grab it, there we go. Could have written it all down by that point. All right, let's do this. Let's add up some like terms. I got a 4x squared plus 12x minus 2x is plus 10x. And then just minus 4. All right? And you just keep it like that. It does have a common 2 in everything here, but you don't have to factor out the 2. Just leave it like that. It's perfectly fine. And then you're good to go. So you've added those, or you subtracted those 2 fractions with uncommon denominators. Guess what? We are at the end. Let's bookmark this and do this last one in whites. All right. This is number, oh, there I go again. Why does it always do that? I hit this button on my pen. I gotta try to keep my fingers away from that dumb button. All right, so I get a 1 over 2 plus 3 over x. That looks easy enough until you do this. But if you remember, that division wasn't so bad, was it? Remember what division is? It's multiplying by the reciprocal. Okay, you keep it, you change it, you flip it. Let's do that right now before I even mess with this stuff on the top. I'm just going to write 1/2 plus 3 over x. Okay, instead of divide, I'm going to do multiply by 4 over x plus 3. I flipped it. Now you got to be careful though. You got to do this stuff first, okay? Because this was the numerator. You got to keep that the same. So you got to do this stuff first, even though this could be confusing the way I wrote it. 3 over x times this. It looks like you would do multiplication first, but in this situation, you got to simplify this first. Maybe I should have done that before I changed it and flipped it, but let's just do this. So I need a common denominator. I could just multiply those together, 2x. Multiply this by x, multiply the top by x. Multiply the x by 2, multiply the top by 2, I get a 6. And now I can go ahead and do this. All right. So what in the world can I do here? Well, there's not a whole lot I can do. Now remember, this is grouped and this is grouped. All right. I can't cancel out the x plus 3 with this. Okay. Oh, I can do this. I got a 2 that's in common with both the top and the bottom. So I can cancel out a 2. Remember, when I cancel, I'm dividing. So I divide this by 2, divide this by 2, I get a 2, and really that's basically my answer. Let's just write it real nice. I always like to stick that number out in front, make this an x plus 6 over an x times x plus 3. That's all we can do with it. Nothing else will cancel out. So number 20 wasn't so bad. I had originally put another problem on number 20 and I worked it out. I was like, oh my goodness, it was tough for me to do. And I was like, I'm not making the students do that one. So I was thinking of you and trying to put something a little bit easier for you. So yeah, that wasn't so bad. So that's it. So this is Sunday night. I'm doing this on Sunday night and it's about 6:45. And I'll tell you about it tomorrow, and I told you Friday to look. So we will review. So if you have any other questions, like why I did stuff, if you didn't feel like watching the whole thing, I am not going to, actually, let me change that. I am not going to tell you tomorrow in class that this review covers the whole test. I will say that there's a lesson up on YouTube, and you better watch it for your own good. I will say that. So what I'm going to do tomorrow is just take questions. And if you have questions, if you've watched this video to the bitter end, I know it's been long, but if you've watched it to the bitter end, ask questions on some of this stuff if you still weren't able to get it. So remember, the test is on Wednesday. I don't know what the date is. Let's see what the date is on Wednesday. It would be the 27th. Okay, so, and then the corrections will be on Thursday. You need to be there for both of these, okay? 10, 20, 8. All right, you need to be there for both of these. They're not first period. Neither one of these classes are first period, so there's no reason to be late. Be on time. I don't care what your excuse is. Be on time because we don't have school on Friday, right? This Thursday right here is the absolute last day of the marking period, so we do not have school on Friday. So make sure that you're here to do this because you don't want to incomplete. You don't want to put off taking this test. So there you go. Well, I hope that was helpful. Sorry it went so long, but I'm going to stop recording and hopefully this might help you out a little bit. All right, we'll see you later. Bye.